Hello, my name is Sufyan, and this is our work on deep active learning for joint classification and segmentation with weak annotator. Standard weakly supervised methods often rely on CAMs to obtain a region of interest using only global annotation. However, those methods face two main issues. The first one is low resolution of CAMs that lead to poor segmentation, and the second one is when dealing with complex images like histology images, those methods tend to fail to localize the region of interest. In this work, we propose a method that allows to provide full resolution of CAMs that are trained using pixel-wise supervision, but under limited budget. And to do so, we use active learning combined with label propagation mechanism to allow to increase the number of labeled samples to fast improve the performance of the model. To explore the two types of annotation, we use this architecture that allows supervised classification training and also supervised segmentation training. To obtain pixel-wise supervision, we use standard active learning, where typically there is a labeled pool where we select some samples, then we ask the oracle to label them, and then we use those labeled samples to train the model, and we repeat this process several times. In our method, we use the same process. However, we use additional components that allows to perform a second selection on the labeled samples, but this time we use the model to pseudo-label them instead of the oracle. And the idea here is to increase the number of labeled samples to fast improve the performance of the model. And both types of samples are combined in the training of the model, and we use a lambda to account for the authenticity of the pseudo-labeled samples. Now, those samples, or additional samples that we select, we use KNN to select them, and where we perform KNN over samples of the same class. For each sample, we look in its neighborhood. For each labeled sample, we look in its neighborhood, and if there is a labeled sample, we pseudo-label that sample. And the assumption here is that pseudo-labeled sample is more likely to be assigned a good segmentation by the model because there is a labeled sample nearby. This architecture is trained in two steps. The first one, we train the classifier and then freeze it, and then second, we train the segmenter head. And the reason for this separation is to avoid interference between two tasks to perform a more accurate analysis of active learning on the segmentation task. Because if you train both tasks simultaneously, there will be more issues, mainly due to the imbalance of the supervision, where the entire dataset is labeled globally, but there is only very few samples that are labeled at pixel level. In terms of experimentation, we evaluate all the methods on two datasets, and we use this protocol for active learning. For the first iteration of active learning, we label only few samples per class, and then the next iterations we label only one sample per class, and the reason for this is to use more realistic load on the annotator. And the results show that our method that uses only random selection outperforms overall the other methods, and this is due to the additional supervision obtained from self-learning of our model. If we consider this case of cube, in particular the first round of active learning, we see that by labeling only one sample per class, we obtain a gain of around 20% of dice compared to the weakly supervised method, which is an important result in practice to consider. We measured the performance of pseudo-labeled samples, and we found out that through active learning iteration, that performance improves, which in turn helps improving the model accuracy. We perform an ablation study over the two hyperparameters of our method, the K for KNN and lambda, and we found out that our method is less sensitive in terms of K, but relatively sensitive in terms of lambda, depending on the complexity of the dataset. For example, cube is more complex dataset, and this provides more noisy to the segmentation. Therefore, we recommend using small value of lambda. Our code is available at this GitHub link, and please visit our paper at this number. Thank you very much.